Welcome to Innovation Explorers. Experience the captivating realm of innovation, design, science, and technology. How do autonomous vehicles operate? A vehicle that can sense its surroundings and function without human intervention is an autonomous vehicle. There is no requirement for a human passenger to operate the car at any moment or even to be inside the vehicle at all. An autonomous vehicle can go anywhere a traditional vehicle can go and can perform any task that a skilled human driver can. In order to run software, autonomous automobiles need sensors, actuators, sophisticated algorithms, machine learning systems, and potent CPUs. Based on a number of sensors positioned throughout the vehicle, autonomous automobiles build and update a map of their surroundings. Radar sensors keep track of the whereabouts of adjacent automobiles. Traffic lights, road signs, other vehicles, and pedestrians are all detected by video cameras. LiDAR, light detection and ranging. Sensors estimate distances, find road boundaries, and recognize lane markers by reflecting light pulses off the environment around the car. When parking, ultrasonic sensors on the wheels pick up on curbs and other cars. What problems do autonomous cars face? Several regions of the world are testing fully autonomous, Level 5 vehicles, although none are presently accessible to the general public. Years will pass before that happens. The difficulties range from legal and technological to environmental and philosophical. Here are a few of the unanswered questions. Both radar and LiDAR. LiDAR is pricey and is working to find the ideal ratio of range to resolution. Would LiDAR signals from different autonomous vehicles on the same route clash with one another? Will the frequency range be large enough to facilitate the mass production of driverless automobiles if many radio frequencies are available? Weather circumstances. What happens when a self-driving car travels through a lot of rain? Lane markers vanish when the road is covered in snow. If the lane markings are covered in water, grease, ice, or debris, how will the cameras and sensors be able to follow them? Laws and traffic conditions. Will driverless vehicles encounter difficulties on bridges or in tunnels? How will they perform in heavy traffic? Will autonomous vehicles be limited to a particular lane? Will they be permitted to use the carpool lane? And what about the fleet of vintage vehicles that will continue to circulate on the roads for the next 20 or 30 years? Federal vs. state regulation. Recently, state-by-state regulations have replaced federal guidelines as the primary form of regulation in the US for autonomous vehicles. To stop the rise of zombie cars roaming the streets without occupants, some jurisdictions have even suggested a per-mile charge on autonomous vehicles. Additionally, lawmakers have proposed measures that would require all autonomous vehicles to be zero-emission vehicles and to be equipped with panic buttons. But will there be variations in the legislation from one state to another? Can you drive an autonomous vehicle over state lines? Injury responsibility. Who is responsible for accidents brought on by autonomous vehicles? Who is the producer? The traveling individual. A human passenger wouldn't even have the option to take control of the vehicle in an emergency, according to the most recent designs, because a completely autonomous Level 5 automobile won't have a dashboard or a steering wheel. Emotional vs. artificial intelligence. To make split-second decisions and anticipate behaviors, human drivers rely on subtle indicators and non-verbal communication, such as making eye contact with pedestrians and interpreting the body language and facial expressions of other drivers. Will self-driving vehicles be able to reproduce this connection? Will they possess the same instincts for saving lives as human drivers? What advantages do autonomous vehicles offer? The possibilities for increasing ease and quality of life are endless. The physically challenged and the elderly would be independent. The automobile could transport your children's forgotten toothbrushes and swimming suits if they were away at summer camp. Even better, arrange for your dog to visit a veterinarian. However, the main benefit of autonomous vehicles is their ability to significantly reduce CO2 emissions. In a recent study, experts highlighted 3 trends: vehicle automation, vehicle electrification, and ride-sharing that, if implemented together, would fully realize the potential of autonomous vehicles. These 3 revolutions in urban transportation by 2050 might be able to reduce the number of automobiles on the road by 30%, reduce the cost of transportation by 40%, including infrastructure, fuel, and cars, increasing livability and accessibility, safe parking lots for community centers, parks, and other purposes. Worldwide 80% reduction of urban CO2 emissions. Autonomous cars, also known as self-driving cars or driverless cars, are vehicles equipped with advanced technologies that enable them to operate without human intervention. These vehicles use a combination of sensors, software, and artificial intelligence to perceive their environment, make decisions, and control their movement. The goal of autonomous cars is to enhance road safety, improve traffic efficiency, and provide more convenient transportation options. The development of autonomous cars represents a significant technological advancement that has the potential to transform the way we think about transportation. However, it also comes with technical, ethical, regulatory, and societal challenges that need to be carefully addressed for their successful integration into our roads.